Yeah, so I'm Samantha Quin. I work for Politico. Are you guys familiar with Politico? Imagine technology. So I work in Politico and lead developer there. We're a political journalism company based out of Washington, D.C., actually Arlington, Virginia, just across the river. And my Twitter and my web feeds and all that kind of good stuff. So just to give you some background about what I want to talk about, and this is not a deeply technical talk, but a number of years ago I was working on a project where we had this legacy application, and we allowed customers to integrate with that application basically by ingesting XML files that it output. And we wanted to modernize it. And more importantly, we wanted to let our integrators get access to that data while it was still being collected and processed. So we decided we're going to put a REST API into this thing. And no one on my team had ever done that before. We actually weren't web developers. But I did some research because I like to do things right, or as right as I can. And what I found doing this research was that there's a lot of conflicting information about what REST is, what RESTful means, and even about a lot of the technicalities of the HTTP protocol. So what I hope to do here is to maybe clear up some of these misconceptions and start a dialogue about what all of this stuff means, what it means to do REST the right way, build an acceptance of the fact that right now, in the way technology is, it's not exactly possible to do everything the right way all the time. But I think if you have a good understanding of why these things are done, that'll help you out. So we can start with the question, what is REST? You guys probably know it's an acronym. It stands for Representational State Transfer. It's an architectural style that describes an agreed upon set of rules for delivering content in a distributed network. And this part is a little bit academic, so bear with me, but by the end you'll have a better understanding of how and why this information applies to the way we try to solve real problems today. This guy is Roy Fielding. In his doctoral dissertation, he described REST. He actually described it, interestingly, as a set of constraints that we can apply to the elements of a hypermedia-driven system. So you probably can't read this very well, but this is text. And we all know this is English text. Does anybody recognize it? Out of curiosity? From Jules Verne's from the Earth Simulator. Back in the 60s, though, some really smart guys like Ted Nelson and Doug Engelbart started experimenting with ways to use computers to enrich text and to enrich the experience of consuming information as text. And what they came up with is this concept of hypertext or hypermedia. And at the risk of making something complicated that's actually pretty simple, the center of the idea of hypertext is that if you let information link to related information, we can increase the information density a lot. So this pattern is really familiar. You've seen it like on Wikipedia and every other website in the world. Where you have a piece of text that links out to a more detailed description of what that concept is. So if you're reading this text and maybe you don't know what mass is because you never took high school physics, you can get that information. Or you can learn about cotton or nitric acid or Brackenow, who's actually a real person, that Verne was apparently obsessed with. So like I said, Fielding describes REST as a set of constraints. And it's a little strange at first, but I want to walk you through his thinking and through those constraints because I think it helps to put the pattern into a good perspective. When we design applications, we tend to start with a blank whiteboard, and I definitely do the same thing. And we start to draw in the elements that we need to build up our application. And then we kind of draw a line between them to indicate how data flows back and forth. In the end, hopefully we we make everybody happy. We have a smile monkey. Fielding approached the problem with REST, more specifically with HTTP, by starting with what he calls a null style. By envisioning the web as this sort of, I don't want to call it amorphous, but somewhat unstructured collection of content, hypermedia documents, images, and all this kind of stuff. And then by applying constraints in an incremental way, bringing all of that system into some kind of order. So we have this hypermedia network with all this stuff that references other stuff. It's floating out there in a big blob. We want to organize it all. Specifically, we're trying to define a set of guidelines that all of the consumers of hypermedia can agree on. We want to be able to access each other's stuff without having to go through this long, complicated process of figuring out each other's protocols and all kinds of different interfaces, which is a big mess. So we start with this empty null style. It's an empty set of constraints. There's no boundaries between any of the components that make up the web at this point. And the first constraint that we apply is a client-server architecture. So we divide the system into clients and servers. The servers store hypermedia. The clients manage the display of it. They manage the user interface portion of it. So we have a separation of concerns between the storage of the hypermedia, the actual documents and the relationships between them, and how that data is going to be consumed by the end users. Because the user interface is completely up to the client, it's very easy to have a lot of portability for this platform. I don't know how many devices you have on your person right now that have a web browser on them, but I've got about 4. Between my laptop, my phone, my Kindle, my tablet. So I think we can agree that this platform has become very, very portable and broadly distributed. So the second constraint is statelessness, which is a little bit weird, but what we're going for is that the requests contain all the information that you need to fulfill them. The server itself doesn't maintain any application state, and that's kind of a tricky statement because the server certainly does have state, but it's not related to the application. There's state related to how it's managing that stuff, but the information itself is stateless. Point being that there's no shared context between the client and server beyond the read protocol about how we're going to retrieve this information. When we ask for something, we don't want to rely on that shared context between the client and server. The server doesn't know what the next kitty pig is. We want to request precisely what we want. So what does that buy us? Actually, it buys us a lot. First, we have a system that's a lot more stable. Because the state is totally managed by the client, a failure in the server is not catastrophic. So when we put this fire out, and the server comes back up, we can start making requests again, and the server just picks back up where it left off. This also lets us spread that risk among multiple servers. Because there's no maintained state, we can bounce that request from a bad server to a good server. We also get a lot of scalability for that same reason. When there's no state to maintain on the server side, it makes the server's code simpler, and it lets the server free up resources more quickly. And like I said, because there's no state, it doesn't really matter which server in a cluster handles a response to a request. The response is always going to be the same. And lastly, it gives us some visibility into what's going on. When there's no internal state, bugs can be more easily reproduced. If you know that sending a specific type of request always results in an unexpected response, submitting that request should always result in that unexpected response. Because there's no, obviously unless the server is just completely jacked up. But all the information that's causing that unexpected response should be in the context of the request. The next constraint is that the output of these hypermedia servers should be cacheable. Transmitting all this state increases network overhead by quite a bit, so one of the ways that we alleviate that is with client-side caching. The idea being here that we stick an expiry date on resources when we serve them. The clients have the option of waiting until a copy of the resource expires to request it again. This was adopted really very quickly and very well by web browser developers over the years. So it's actually, I'm sure that you've run into situations where you can't get the cache to clear, and you're just getting this bogus stuff over there again. Web browsers like to do this. The next constraint is that the system has a uniform interface. More importantly, that resources have a unique global identifier. And this image is located in that dual element, actually. So that's a globally unique identifier in terms of the web. We manipulate these resources through representations. You probably interact with these mostly in the form of either HTML documents or JSON objects that you send back and forth from your APIs. The resources themselves and the abstraction and the representations are slightly different, and we'll get into that in a little bit. But the next important part of this constraint is that the requests themselves are self-contained. The messages are self-descriptive, and they contain all the information that the server needs to understand them. And there's also this principle here called Hypermedia, is the engine of application state, which you've probably heard a million times. I think it's one of the best acronyms in computer science. But what this means is that state transitions have to happen in the context of the information contained in a representation. So what the hell does that mean? When we request a document, we get back some information about related documents. In this case, we have a link to the organizer of this event. We're going to get wild to this. Not really. These links let the API describe the relationships between objects without having any previous knowledge of the API structure. So ideally, in a perfect world, the client should be able to connect to the index of a Hypermedia server and get all the information it needs to navigate through any resource that it has access to, just by making requests and evaluating the responses. So what about JSON? We all love JSON. It's not a Hypermedia format. There's really no way to get around that. It's getting better, but JSON doesn't have a universal standard for expressing relationships between resources like HTML and XML do. And that's a problem because if you aren't including those Hypermedia relationships, you're not doing REST. You're doing something very REST-like, but you're not doing REST. If we look at this object that we get back, we see that there's no links to anything. This is useful information, certainly. If we have a nice API documentation, we can say that if you need to get the organizer for an event, you just append /organizer, and you can do this in this nice Swagger documentation, which we abuse a lot at Politico. But it's really not RESTful. So am I saying use XML for everything? Obviously not. The answer here is to make JSON into a Hypermedia format. And this is actually an interesting area. There's a couple of different pushes to do this in a couple of different ways. One of them is JSON hyperschema, and if you're not familiar with JSON schema, it's just a way of describing JSON objects, and they have this extension called JSON hyperschema, which allows you to also describe the links that could be related to a given object. The one that we actually use at Politico is called the Hypertext application language. It's a proposed standard for extending JSON to become a Hypermedia format, and this guy, Mike Kelly, wrote the draft of the RFC. It doesn't have a lot of acceptance, but it seems like maybe it's growing. I don't know if it's the right answer, but it kind of works for us. To give you a very limited example of what it does, is it sets up a standard of these links and embedded, sort of private attributes of this JSON object that include relationship information, right? So it lets us express those relationships inside the document, and importantly, it lets us do it in a way that is standard across hopefully all implementations. So if this became the global standard for building REST APIs using JSON, you wouldn't need to know that a particular API was doing this before you started to interact with it. There are a lot of important discussions in the community about this. There will continue to be a lot of important discussions in the community about this. It's actually really exciting to see that real acceptance of REST is picking up more and more and more. And hopefully within the next few years, we'll all have the opportunity to define a really cool standard. So get involved if you can, if you're interested. Back to the constraints. The next one up is layering. We see this a lot when we go through proxies or load balancers. The idea here being that any two components of the system can only really see each other. They don't know what lies beyond. The transaction, no matter how deep it goes into some network, is transparent to the other side of the connection. This lets us build out systems that are really quite complicated while abstracting away and hiding a lot of that complexity from the other components of the system. The next constraint is code on demand, and this is considered an optional constraint, but we see it a lot, mostly in web pages, with stuff like JavaScript, and in the past, Java and Flash, maybe not in the past enough. But the idea here, and I actually think this is an interesting idea. This lets you, as an API developer, or as a server, when you're developing a resource that you're going to serve, to include information that instructs the client how to interpret or process or execute the information that you're returning to them, which means that you, as a server developer, can extend the functionality of your consumer's client without the person who developed that client having any clue what you're doing. Now, obviously, there needs to be some standards involved, and that's really what JavaScript is. It's a standard scripting language. Flash is a corporate standard, same thing with well, Java's a little bit more open, but not much. But using these agreed upon methods, you can actually extend the functionality of your consumer's clients without having to get Microsoft and Apple and Mozilla to all agree and implement this stuff in the browsers ahead of time. We're going to talk a little bit about resources and representations and how they link together to form RESTful systems. But there are four big concepts that I want you to consider. Obviously, resources, representations, and then metadata and control data, which are maybe not as appreciated as they should be. Resources are a temporarily varying membership functions, which for a given time map to a set of entities or values which are equivalent. Anybody, unless you have recently gotten a CS degree. A resource is an abstraction of some entity or some collection of entities that we can identify by name. And when I say abstraction, I mean an abstraction. These are all valid resources. The Ocelot picture from before, all accounts created on October 12th, the most 100 recent tweets about Kim Ye's baby. These are logical associations that have a meaning at a certain time. The thing that's interesting about resources, or important about them rather, is that every resource has a name. On the web, we use URIs, which can be any combination of a locator and a resource name, but they uniquely identify a resource on the network. So going back to my Ocelot, this is a resource called 5c015ve.jpg. It's available via HTTP from i.imager.com. In the case of an API, you might have a resource 201 that's a sub-resource of a resource collection called events. It's available via HTTP secure from API.com. So these are two resources that exist in the same overarching system, the web, that have unique identifiers that can be addressed from any point within the network. So while resources are abstractions, representations are concretions. Skip slide. In order to interact with a resource, we use this representation. And they consist basically of data and metadata. Sometimes they also consist of metadata that describes the metadata, which is a little bit confusing, but that's sometimes when we put in a checksum that lets us check to see if the message that we got has been corrupted, or maybe it was not from who we expected it to be from. So let's say we request an account from this API, and we get back some data, and we have a little bit of metadata here telling us that the media type that we're getting back is a JSON object, and sure enough, we get one back, and that object is a representation of an account entity that lives inside this service somewhere. So, like I said, where resources are abstract, representations are concrete. Representations are the actual bytes that get transferred between computers. They consist of the data itself, descriptive metadata. Sometimes this is referred to as the file or the document or the message entity, depends on what your context is. And then there's this control data, which is used by the client and the server to kind of coordinate the transmission. Has anybody here worked with content type negotiation in the past? A little bit? Yeah, it's kind of annoying. It's not really very well supported. But it's a great idea. I mean, you can basically say, hi, I'm a client, I need this data, and I know how to parse JSON and YAML. And the server says, well, okay, I have this data, I know how to speak, I know how to speak JSON and XML. Oh, well, we can do JSON. So, like again, in a perfect world, this would happen all the time. It very rarely works very well. There's also cache control information that gets transmitted here. So what I was saying about putting an expiry date on a resource, you can say that this this object was last modified at a certain date and time. We can say that it was that it's valid for the next 10 minutes. So going into HTTP, which I think is necessary to talk about when we start talking about this, because all of the way that these concepts are leveraged in the terms of the web is via this protocol that was documented in the early 1990s. And I think first published in 1991 and then expanded a number of times over the years. It's a very, very simple protocol. If you have a chance to read the RFC, you should. It's not very long. But basically, we have originally 8 methods, now 9, and about 40-ish standard response codes. It's a line protocol that follows this simple request and response cycle. So the client opens a connection to a server. The client sends through a request consisting of a method. What do I want to do? A resource. What do I want to do that to or with? And possibly some metadata, control data, whatever. And then the server responds with a status line to let the client know if that was a successful operation or not. And potentially that some resource entity as a representation of a resource, and some meta and control data. So it just goes, very simple. The methods that we have some safe methods and some unsafe methods. And obviously when I say safe and unsafe, I don't mean don't use the unsafe ones, but more that when you execute a safe method, there's kind of an implicit promise there that you're not going to change anything. With unsafe methods, that's certainly not the case. And then there's connect, which usually gets stuck up there with the safe method, but I want to call it out specifically because it's kind of weird and it's only used for certain things, and we'll come back to it later. Get, which is the one that we all use all the time, simply requests a representation of a resource. So when you hit a web page, you're just sending a get, it's sending you back an HTML document, which is a representation. This is a safe method. It should have no side effects. We'll talk about that when we talk about anti-patterns, but if get is doing something, get has been implemented wrong. We won't give a lot of time to head and options and trace. These are all important and interesting in their own way, but not used particularly often. So with a head, it's assuming the same as a get request, but it won't return that message representation, that object representation rather. It just returns the headers. When you do an options, it asks the server to respond with what methods a particular resource accepts. So if you ask for the resource called foo with options, it'll tell you, well, you can get foo and you can put foo. Good for you. And then trace actually asks that the server echo back the request, which can be used to validate or kind of troubleshoot things that are going back and forth. Crazy. And by the way, I don't know if there are any soccer fans, but if this thing starts making a lot of noise, I kind of have like the Liverpool game. I get like notifications when stuff happens, so don't be surprised. And then moving into like delete does exactly what you would think delete does. Put creates or overwrites a resource. So specifically, it overwrites or creates a resource when you already know what the ID of that resource is. So we're going to put accounts 43, which includes some representation. The server should store it. Post asks the server to store an entity as a sub-resource of a specified resource. So in case we want to create a new account, we can post two accounts. It should create a sub-resource there and potentially return us back some information about how to interact with that new resource that it's created. So my throat is starting to give out on me. You want to use post when you need to annotate an existing resource. Posting a comment to a blog, post to a forum, sending in a block of data that you want to have processed some way, adding a record to a database. These are kind of where you use these post operations. I found when I was initially doing research and trying to figure out which to use, put or post, I found tons and tons of conflicting information. And I think it's gotten a little bit better in the 5 or 6 years since we first set out on that path. But the basic difference here is that put creates or replaces a resource with a known identifier, and post creates or replaces a resource that is a sub-resource and another resource. There are other uses of post, but this is kind of how the RFC defines it. It's one of the little quirks that I love, because when you do search Google, you'll often find things that completely contradict one another talking about this topic. And sometimes you come away a lot more confused than you started. Especially because they're kind of doing the same thing, but they're just making some slightly different promises about how they're going to do it. The key difference there is this concept of idempotence, which actually comes from mathematics. And what you mean when you say that an operation is idempotent is that no matter how many times you can run it once and then run it 10,000 more times, and you'll continue to get the same response over and over and over again. So all of those safe methods that we talked about before are by definition idempotent. If you get a resource 100,000 times, you should always get the same resource back. Put is an idempotent method, along with delete and get and trace and options and head. And then there are these two over on the side, post and patch, that are not considered idempotent, meaning if you run them more than one time, you may get back different results each time you do it. And a good question that comes up a lot is, how is delete an idempotent method, since when you delete a resource, you get back a 204, no content, and then if you do it again, you get a 404. Because obviously the resource doesn't exist anymore. You might have to get back a 410 gone. But the point here is that the resource is just as deleted on those subsequent requests. So the actual state of the application doesn't change. What I just said. So to reduce it even more, the essential difference between put and post is that put is idempotent and post is not always idempotent. You want to use put to create or replace resources, whose identifier you know, post to create sub-resources. If I want to put my talk into this talks resource, my information. That's great. I can now do this get as many times as I want, continue to get back the same information. If I post this little bit as a sub-resource 1,000 times, assuming that the server's not doing any duplicate checking. But that brings us to patch, which is the newest method. This was only started to gain acceptance since like 2010, so it's very recent. This kind of requests that a server apply a partial modification to a specific resource. So if you have a resource and you want to change some of the elements of that resource, some of the attributes of that resource, you can theoretically use a patch operation. Now, it's not widely accepted because there is not yet a standard way of doing this. The reason that they introduced this whole patch idea, though, is that what requires is to transmit a complete modified resource. So you have a resource, you modify one element of it, you have to send the whole thing back. Some of our resource representations in our APIs that we use are very, very large. When I say very, very large, I mean on the order of a few hundred kilobytes, but when done millions of times over the course of a day, it really starts to add up. So patch, just in brief, lets us cut down to just what we need to change. But there are a lot of considerations, though. If you have a patch operation that depends on, oh, I'm sorry.
When you do a traditional put, you have to do a get first to get the object of the modification. So it's 2 calls.
Right. Well, unless you want to just replace it blindly.
Yeah.
Yeah. So if you require this resource to be in a certain state for your patch operation to happen successfully, and something gets in there first, another patch operation or put operation, you could have a conflict. You could have a collision. It's not a good thing. So you have to be very cognizant when you're writing these kind of patch operations that they don't rely on state. So one of we'll talk about one of the standards that's kind of coming forward, but there is this proposed standard for JSON patch, and patching in XML is kind of supported, not very well. So it's there. So there's this proposed standard called JSON patch, and it lets you define some operations, so remove, add, replace, move, copy. If this standard becomes a standard and gains some adoption, we might start to see patch implemented a little bit more frequently. We actually use it very heavily, and we are using this standard. It works really well for us for the most part. So one of the other, I've seen actually an implementation that actually submits diffs, actual context diffs, against which is kind of scary. So yeah, so there's JSON patch. And not to forget connect. It is an HTTP method. It's defined in the RFC. It's used with proxies to allow for tunneling. So if you connect to a proxy and then you send a connect method, it can create a tunnel connection for you. It's interesting and boring at the same time. And then, like I mentioned, and I'm not going to go through them all, but there are a bunch of standard status codes, and they're grouped into little sections. So 100s are informational, 200s are indicated success, 300s are some type of redirection, and then you have your errors 400 and 500, depending on who screwed the pooch. So I want to talk a little bit about building good APIs. And like I said, I'm not going to get too technical, but there's just some ideas that I want you to keep in mind. One is that REST is about hypermedia. The whole point of this is to deliver resources and their relationships in a way that lets clients consume them and work with them, modify them, retransmit them without having to have like this pre-knowledge of how the API is structured. So if you can live and breathe Hypermedia as the engine of application state, even when your implementation media type doesn't support it well, you're doing yourself a favor. And like I said before, these are evolving standards, so trying things out and communicating about your successes and failures will help to drive that forward. The primary consideration here is how can you make your resources easy to consume by clients without having to explain everything ahead of time. And of course, you want to avoid anti-patterns like get abuse. This is not REST, this is RPC. Like the world uses RPC. You don't want to abuse get by tunneling everything through get, by indicating operations as a sub-resource. It's not the right way to do things, and it's also very difficult to document and describe, and I have to give that information to the client ahead of time to give them a document saying, if you want to delete this resource, you have to send a get request to the resource, and then the operation, maybe it's delete, maybe it's edit, maybe it's update, maybe it's not even consistent within that application, which is kind of scary, so don't do this. Likewise, don't abuse post for the same reasons. Sometimes, oh, well, post is great, because you know, it's a little bit easier to create gigantic content query strings, so it's either bad idea. And another important one is not using the incorrect response codes. There's a lot of APIs out there that respond with a 200 or a 500. That's not really helpful. There's actually a very rich number of status codes available in HTTP that have well-defined meanings, and like I said, I don't want to go into them, but if you peruse the RFC, it kind of explains them, and by providing these standard status codes, you can let clients respond in a way, in a more programmatic way. So they know if they get back a 404 that the resource doesn't exist, and they can re-ask it again. Do you have a question?
Yeah, I was going to say, if you do use delete, what would be an example of a good response code to send back?
Delete should return a 204 no content.
No content.
Yeah. So using the right status codes, it's again, the whole idea here is that these are standards that everyone's agreed on. So if you send back the right status code, the client knows how to respond to it. They don't have to like parse your JSON for the success key and see if it's true or false, and then read the exception message. And yes, not good. And ignoring hypermedia is something that I've really been guilty about, because no one wants to work with XML. Everyone wants to create JSON APIs, and JSON doesn't make it easy. Like I said, there are some emerging standards to help with this, but even though these standards are emerging, a lot of the tools that we use to build APIs don't support them very well. Hopefully that will change as we're seeing some new kind of API-focused frameworks and tools that are being built. I believe one of them was discussed at a talk here yesterday, Bullet. I don't know if anybody caught that. Oh, someone scored a goal. Looks like disaster bill, that's not good. So representations need to have links to related resources. So do this however you can. Obviously, you want to try and follow one of these standards if it's possible. If you're working solely with a private API that you're never going to expose to the public, I guess it's kind of not horrible to do what works for you. But the point being that you're not doing REST if your resources aren't expressing their relationships. These are some really important things to read. RFCs are not that scary to read. They're usually not that long. JSON HAL and JSON Patch are those two standards that I were talking about, and I really suggest looking at them. They're not perfect by any extent of the imagination, but you know, an RFC is a request for comments. So experimenting with them, finding their strengths and weaknesses, and working together as a community to make them better is kind of what open source is all about. So sometimes it's not just code, but it's how we write code that's important. So I also included a link to Roy Fielding's dissertation, which is chapter 5 covers REST. It's again a couple of pages long. It goes a little bit into computer science theory if that's not your bag, but it's not too much, so it's not, you can just kind of skip over anytime you see like function notation. And then this is actually a really good resource, REST code work. It's not that much information there, but what's there is pretty solid. It gives some information. It kind of hates on Json a little bit, but whatever, haters gonna hate. And yeah, so I'll open it up to questions and leave this up here if you have feedback or if you just want to get in touch with me with some info.